Here we have the same two functions as we had in example 1. We found that f of g of x was 3x squared minus 1. Since the function g was done first, its domain would be the domain for the composite function. So therefore the domain for this function is x belongs to the reals. The question we now want to ask is what is the range for this function? Let's once again consider calculating machines. The input first goes in to the function g, and this input could be any real number from minus infinity to infinity. It goes into g, and g is a function which squares. The graph of x squared looks like this, so the range for this function is reals which are greater than or equal to 0, and therefore only reals greater than or equal to 0 will end up going into the next function. So now let's look at f. This is 3x minus 1, and the graph of 3x minus 1 is a straight line with gradient 3 and y-intercept minus 1. Because of the domain, this part of the line will not exist. Our domain is only numbers from 0 upwards. If we now look at the y-axis, we can see that the range, the output, is going to be real numbers, but greater than or equal to minus 1. The range then will be y is a real number, y greater than or equal to minus 1. Now let's consider g of f of x, which we found to be 3x minus 1 squared. The domain for the first function is x belongs to reals, so this will be the domain for the compound function. Once again, we want to discuss the range for g of f. Let's look at calculating machines again. Here we have the function f, and real values are going to go into it. F produces a straight line graph 3x minus 1, and this graph will have all output values from minus infinity to infinity. Therefore all of the reals come out and act as input to the next function. The function x squared looks like this and has a range greater than or equal to 0. So only positive values come out. The range for this composite function then is y belongs to reals, y is greater than or equal to 0.